Unit 5, Part 7. So we've just run through 1D, exercise 1D, the truth table test for the validity of this argument form. And we saw in the second premise, we had to calculate the sub-formula before we calculated the truth table column for the formula as a whole. Right? So we do this one and then this one. That is what you can keep in mind. Should make it easier for you to understand. Klenk's brackets 1, 2, 3 on page 80 and 82, where she, that's just the order. So the 1, 2, and 3 down the bottom of here, it's just indicating the order, as she explains, the order in which she computes the columns. Right? She has to compute the sub-formulas before you can compute the formula itself. And as I said, I'm going to do an example for a short truth table method in a minute. And it will be useful to keep in mind excuse me, the alternate way of expressing what a substitution instance that I mentioned in the last part. A substitution instance is a row in a formula, but you can also think of a substitution instance of an argument form as a particular assignment of truth values to the sentential variables. Okay, the short truth table method will pick up on that. Right, so we're testing an argument form for validity. That's testing whether the counterexamples exist or not. What is a counterexample? It's a row in a truth table, or it's an assignment of truth values to the simple components, right? So we don't have any counterexamples in this one, but in the last one, it was when P is true and Q is false, on that assignment of truth values to the sentential variables, what happens? The premises come out true and the conclusion comes out false. That assignment of truth values, P equals true, P equals true, Q equals true, whatever it was, that assignment of truth values to those simple components determines the premises as true and the conclusion false, right? Okay, so that's what we've been doing is the full truth table method. That gives you everything you need to know from section 2 of the book. You can, as I say, page 79 where it starts. The opening paragraph really is everything we've been doing, right? It's as simple as this. If you understand this opening paragraph and can do what it says you need to do, you understand what you need to answer the biggest questions in the exam, the truth table tests for an argument's validity. So 79, opening section. Once you have drawn up the base columns for an argument form, that was explained in section 1, testing the argument form for validity is relatively easy. You simply, 1, compute the truth values for the premises and the conclusion of the argument form for each row in the truth table, and then 2, check the completed table to see whether there are any rows with all the premises true and the conclusion false. If there are, the form is invalid. If there are not, it is valid. Right? A row in a truth table that has all the premises true with a conclusion false is called the counterexample to that argument form, since it shows the form is not invalid. All right, that's the full truth table method. Klenk discusses the partial truth table method, which are not in section 3, shortcut validity tests, it's called. Don't worry too much about the partial truth table method, but I'll explain what it is. If your question in the exam asks you to use the full truth table method, make sure you do. I should say here, the exam is graded where you are given partial marks if you make mistakes, but you have some, say, truth tables correct. Right? So I usually assign points by the truth table column under the major operator. So if you get the first premise right and the second premise right, but the table, if you compute the table for the conclusion wrong, you'll get the partial marks for getting the first 2 right, and you'll lose marks for getting the last one wrong. But this means if you're asked to do a full truth table method, do compute the whole truth table. It won't be too much work to do. Compute every value. I'm saying don't use the partial truth table method, which I'm about to explain. If you're asked to use the full truth table method, compute all the truth tables. You could easily miss out on partial marks if you don't do so, even if you get it otherwise completely right. But anyway, the partial truth table method is a shortcut, right? It relies, to be able to use it properly, you need to understand clearly what you're doing in a truth table test for an argument form's validity, right? You're looking for a counterexample. That is, you're looking for an assignment of truth values to the sentential variables that make the premises true and the conclusion false. Now imagine you had as one premise, right? So you're looking like a terminator for a row where it's t, 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 however many premises there are, false on the as the assignment for the conclusion. False is the truth value for the conclusion. Imagine you had a premise that was the conjunction of P and Q and the conjunction of RS. So imagine you had a premise which was P and Q and R and S, right? So if that was one of your premises and P, Q, and all the other statement forms making up the other premises in the conclusion all consisted of P's and Q's and R and S's, that would give you, okay, when you come to construct the base columns, when you count the sentential variables, I've got a P, I've got a Q, I've got an R, I've got an S, okay? So I've got how many columns? 2, 4, 8, 16 columns. Rows, 16 rows to my truth table. 16 rows, right? True, false, true, false, true, false, true, false, true, true, false, false, true, true, false, false, so on. True, 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 false, 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 true, 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 false, 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 true 8 times, and then false 8 times. That'll be your base columns, right? But notice, this is only going to be true, we're saying this is a premise, it will only be true in one of those 16 columns, right? Namely the top row, where they're all true, right? Because it's a conjunction of conjunctions. If any one of them is false, this formula as a whole, right, what would go into this major, the column that would appear under this operator, the major operator, if any one of them is false, the column would be false, right? The formula as a whole would be false. So the proper column for this would be true, and then 15 falses, right? The first one entry true, when it's true, 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 and every other entry, or at least one of them is false, would be false. Okay, so if you had that as your first premise, you could compute that premise, and then you'd be able to think to yourself, this is using the partial truth table method, which I recommended you against using in the exam, but this is what it is. You would be able to compute the table for the first premise and then say to yourself, aha, the only possible counterexample here is in the first row, right? Rows 2 through 16, 2, 3, 4, 5, all the way through to 16, cannot possibly be counterexamples because the first premise is false in each of those rows. And a counterexample is all premises true. So rows 2 through 16 don't have to, rows 2 through 16 can't possibly be counterexamples, can't possibly be rows that show this invalid. The only way this could be invalid is through the first row. Only the substitution instance that is the first row could possibly be a counterexample. You know that much already after computing the truth table column for the first premise. So that means you could ignore, for your, say, second premise, you, using the partial truth table method, could not bother computing the truth value for rows 2 through 16. You could simply go ahead and compute the truth value for the first row for that premise, and for whatever other premises in conclusion. Only concern yourself with the first row from now on, and if it is the case that that row turns out to be all premises true, conclusion false, if that row turns out to be a counterexample, you say the argument is invalid, but you already know from the falsity of the first premise in rows 2 through 16, you already know that none of the other rows are counterexamples. So if a counterexample doesn't appear in the first row, if, say, one of the other premises is false, or the conclusion is true, you say, okay, the argument form is valid, right? Okay, so that's the partial truth table method. It's important you understand. If you don't understand its justification, you probably don't understand what's going on in general, so it's good to be able to know that, but you probably won't need it for the exam, but maybe you will. Okay, I'll come back in the next part, and I'll be doing, first of all, I'll do 3D, and then I'll do 3A from the exercises, where you'll be using the short truth table method, and this you do need.